All right, today we're going to pull back the curtain on this invisible force that powers pretty much everything we do online. We're talking about the back end. Okay, so think about this for a second. You like a photo on your phone, right? And like instantly your friend who could be halfway across the world gets a little notification. How in the world does that happen? How does that message just get there? I mean, it feels like magic, doesn't it? It's just so instantaneous. But it's not magic. Behind that one little tap, there's this incredible, super high-speed journey of information happening. And that's exactly what we're going to trace. So, to really get what's going on behind the scenes, we've got to talk about the two main players in any app. You've got the front end and you've got the back end. Yeah, basically every single app has these two sides. The front end, that's all the stuff you actually see and touch. The buttons, the pictures, the layout on your screen. But the back end, well, that's the part you don't see. It's the hidden machinery, the engine that makes the whole thing run.
Okay, so what is a backend, really? Well, at its core, it's basically a super powerful computer. We usually call it a server, and its whole job is to be on 24/7, just listening. You can really think of it as the app's brain. It's constantly taking in requests from, millions of users, figuring out what to do with them, and sending back the right info.
All right, let's circle back to our like example. Let's see how this brain actually handles your request. We're going to follow that message every step of the way. Okay, so boom, you tap the like button. First, your phone sends this little tiny message, a request, out onto the internet. Second, that request zips over to the backend server. Third, the server does its thing. It processes it. Fourth, it then shoots a new message all the way to your friend's phone. And finally, fifth, that notification pops up on their screen. And all of this happens in like the blink of an eye. But what's really going on in that processing step? I mean, it's not just one thing. The back end is running this whole checklist. It has to figure out who you are. It has to check if you're even allowed to like that photo. Then it saves your like into a giant database. Then it has to find out whose post you liked, find your friend out of millions of other people, and then it can finally send that notification. It's this incredibly complex but perfectly coordinated dance of data. And all of this brings us to the most fundamental reason a backend even exists in the first place. It's all about a concept called the single source of truth. Just think about it for a sec. The app on your phone, it's all about you. It knows your profile, who you follow, your messages. It has absolutely no idea what's going on with your friend's account. And their app knows nothing about yours. See? You both have a totally incomplete picture of the world. So, if every single app is living in its own little bubble, where's the one place that knows everything? What's keeping track of every single user, every post, every comment, every like, all at the same time? And this right here is the crucial point. If you strip away all the complicated stuff, the servers, the code, the networks, the entire reason the backend exists, it all comes down to one single word. Data. That's it. That's the whole game. The backend's number one job is to be the guardian, the manager of all the application's data. It's the single source of truth that makes sure everyone is on the same page. Okay, but this brings up a really good question, right? Our phones are crazy powerful these days, so why can't they just do all this stuff? Why do we even need a separate central server at all? Well, the answer really comes down to where the code is running. Here's a good way to think about it. Front-end code is like getting a recipe in the mail. The instructions come to your house, and you have to do all the cooking in your kitchen. Back-end code, on the other hand, is like ordering takeout. All the cooking happens at the restaurant in their big professional kitchen, and they just deliver the finished meal to you. The code, the recipe, it never leaves their powerful server. And this is actually a super important security feature. See, your web browser creates something called a sandbox. It's basically this isolated, secure bubble. Any code from a website you visit has to run inside that bubble. And that's what stops some random website from, snooping around and getting access to your personal files or your photos on your computer. But that secure sandbox, while great for safety, creates some pretty big limitations. It means your phone just can't be the backend. And there are 4 big reasons why. It's locked down for security. It can't just connect to any other service it wants. It definitely can't access the app's main database directly. And honestly, it just doesn't have the raw computing power. Just look at how different they are. A backend server, it has full access to files. It has open connections to other services using things we call APIs. It's got a direct line right into the main database, and its computing power is massive and can scale up or down as needed. Your phone's browser? Nope. It's locked down to protect you, and it's just not built for that kind of heavy lifting, not even close. And just think about the sheer scale of it all. A single backend server is built to handle thousands, maybe even millions of requests every single second from people all over the globe. Your phone, it's designed to handle one user, you. The two just aren't in the same league. All right, so let's wrap this up. What if we learned about this hidden engine that's running the web? What it comes down to is this. The back end is that powerful central brain. It's the secure guardian of all our data. It's the tireless workhorse that's processing millions of our requests. And it's the invisible engine that connects you to your friends, to your job, to your entire online world. So the next time you tap that like button, you'll know what's really going on. It's not magic. It's the back end doing its job. And that leaves me with one final thought for you. Now that you can see this invisible system, what other hidden, complex engines are out there, powering the world around you every single day? Have you ever stopped to think about how your phone app, written in, say, Swift, can talk so perfectly with a server that's running a totally different language like Go or Python? It feels like magic, doesn't it? But it's not. It's all about finding a common language. And today, we're going to pull back the curtain on the universal language that really powers the modern web. Okay, let's jump right into the core of the problem. On the left, you've got a classic JavaScript object, something you'd see in your web browser all the time. And on the right, a very specific data structure from a server running on Rust. Now, they're both trying to say the same thing. We've got a user named Alice, but look at them. They're structured in completely different ways. They can't just talk to each other directly. It's a real digital language barrier. So yeah, that's the fundamental challenge right there. We have a client and a server that are basically speaking different native tongues. How in the world do we get them to understand each other and bridge this gap? Let's dig into the why a little bit more. JavaScript, running on the client side, is super flexible and dynamic. You can kind of just throw things together. But the Rust server, it's the complete opposite. It's statically typed, super strict, and compiled. It needs to know exactly what kind of data it's getting. Because of these deep-seated differences, you literally can't send a raw JavaScript object over and expect the Rust server to have any clue what to do with it. Okay, so if they can't talk directly, what's the solution? Well, what do you do when two people don't speak the same language? You get a translator. And that's exactly what we do here. We introduce a universal translator, a standard format that both the client and the server have agreed to speak and understand. This first part of the process has a fancy name, serialization. But honestly, the best way to think about it is just packing a suitcase. You're taking your local data, that JavaScript object, and carefully packing it into a standardized format, getting it all ready to be shipped across the internet. And of course, after the journey, when the suitcase arrives at its destination, what do? You unpack it. And that, you guessed it, is deserialization. The server gets that standard package of data and converts it back into a format it understands natively, like that strict Rust structure. It's that simple. Packing and unpacking. That's the whole game. Now your brain might be spinning, thinking about all the low-level networking stuff happening underneath, all the packets and protocols. But here's the good news. As a developer, you don't really have to worry about that. You're working at what's called the application layer. Your main job is to agree on the what, the format of the data. The complex stuff below is basically a black box that handles the how for you. It just works. All right, so we get why we need a translator and how it works with packing and unpacking. But what is this universal standard that pretty much everyone has agreed on? Well, for the modern web, the answer, overwhelmingly, is JSON. And when I say overwhelmingly, I mean it. Just look at this. While other formats definitely exist, you might hear about XML, it's estimated that JSON is used for about 80% of all this kind of communication. It is, without a doubt, the king of the hill for modern APIs. So what is this stuff? JSON stands for JavaScript Object Notation. And its biggest strengths are right there in the definition. It's lightweight, which means it's fast and doesn't waste bandwidth. It's simple text, and maybe most importantly, it's human readable. You or I can just look at it and immediately understand what's going on, which is a huge win for developers. You know, the real beauty of JSON is just how simple its rules are. First, data is always organized in key value pairs, kind of like a dictionary. The whole thing is wrapped in curly braces. Now, here's a strict one. The keys must be strings and they must be in double quotes. The values, though, that's where you get flexibility. They can be strings, numbers, true or false, a whole list of items, which we call an array, or even another JSON object tucked right inside. And here's what that looks like in the real world. See? It perfectly follows all those rules we just talked about. You've got the curly braces on the outside, all the keys like name and age are strings and double quotes, and look at the values. We've got a string for the name, a number for the age, a boolean for is student, an array for the list of courses, and even a whole nested object for the address. It's so simple, but you can build incredibly complex things with it.
Okay, we've laid out all the individual pieces. Now let's put it all together. We're going to follow a single piece of data on its complete round trip, from the client all the way to the server and all the way back again.
So here's the whole 6-step dance. 1. The client serializes its data into a JSON string. 2. It sends that JSON flying across the network. 3. The server catches it and deserializes it back into a native format it can work with. 4. The server does its job, whatever that may be. Then we just reverse the process. 5. The server serializes its response back into JSON. And finally, 6. The client gets that JSON and deserializes it to show you the updated info on your screen.
Let's make it real. Imagine you want to add a new book to your collection. The client takes the book's details, serializes them into this nice, clean JSON format you see here, and fires it off to the server's /API/books address. And now, here's the server's reply. After it's successfully added the new book, the server might send back the entire updated list of all your books. It serializes that list into this beautiful JSON array. As soon as the client gets this, it can deserialize it and instantly refresh your screen to show the new book. It's seamless.
You know, when you boil it all down, everything we've just talked about comes back to this one really powerful idea. Serialization and deserialization, this process of packing and unpacking data, it's the invisible handshake that makes our incredibly diverse digital world actually work together. So we've seen how powerful and convenient a human-readable format like JSON is, but it does leave us with a fascinating question to chew on. For those times when you need every last drop of performance, for maximum speed, what if we took the humans out of the loop? What if computers had their own, more compact, maybe even binary language to speak just amongst themselves? Well, that's a story for another time.